MFR300 melt flow indexer from Industrial Physics and Rayran. The range-topping MFR300 is equipped with a 5000 pulse per revolution optical rotary encoder to cater for all melt flow testing requirements. Features including Wi-Fi connectivity for results capture, Technitest software supplied for free as standard, and the intuitive icon-driven user interface make the MFR300 a versatile and accessible return on investment, providing detailed results through multi-slicing of melt flow rate data and built-in procedures for all the testing methods from the common international testing standards. Dual zone heating and a power-saving eco mode make the MFR300 accurate and efficient in its operation, suitable for any laboratory. After entering the start screen, you are met with 4 icons on the home screen. Starting from the right, you have the system information screen. From here, you can perform firmware updates to the system or verify the status of other features through the diagnostics button. You can set temperature set points for calibration purposes, view the Wi-Fi connection status, verify the encoder's operation by moving the encoder arm, view any USB or Ethernet connections to the system, and check the operation of the auto cutoff device by performing a cut. Finally, the weight loader operation can be checked, with options to raise and lower the pneumatic mechanism. Returning to the home screen, the next icon is for Quick Start Guides. These provide the user with simple instructions on how to perform tests, saving on time spent reading through the system manual and aiding novice users. The next icon is for the system settings. From here, you can easily adjust the time and date so that your results are logged with the correct timestamps. Next are options for setting up Ethernet and Wi-Fi connections to the system. And finally, there is a pin code protected machine parameters area that is intended for servicing and calibration operations. Finally, the test run icon. Immediately, you're prompted to select an existing operator profile or add a new operator to the system's memory using the alphanumeric QWERTY keyboard. A material reference must be made in the same manner by either selecting an existing material entry or entering a new one. The next screen gives the various testing options on the MFR300. Methods A, B, C, and D from the common testing standards, along with a test for the determination of melt density. Firstly, the user must reference their testing batch before selecting a test type. Starting with a method A test, the typical method for determination of melt flow rate, the user defines the test temperature and preheat time, typically outlined by the testing standard for the sample material being used. The amount of time between each cut is then defined, as well as the total number of cuts to be made. This should be done so that each piece of extruded polymer cut is at least 10 mm in length to ensure a reliable sample mass measurement. The next options for high and low MFR limit are for setting maximum and minimum acceptable MFR values for the test, so that any results outside of the acceptable range are easily identifiable in the test results. Finally, the user can enable the weight loader for the test and set a holdback time value. The holdback time is the amount of time before the end of the preheat period at which the weight loader will drop to apply the test weights to the piston. Using this feature ensures consistency between tests and prevents excessive extrusion of sample material prior to the test starting. With all test parameters set, the system must wait for the barrel temperature to stabilize at the designated value before prompting the user to clean the barrel. This is done simply by running a swab dampened with a cleaning agent through the barrel a few times with the cleaning tool. After confirming the barrel is clean, you are then asked if preheating of the piston is required. This must be done for the initial test performed on the system as outlined by the test standards, but is not required between subsequent test runs. It is then time to charge the barrel. Using the filling funnel, pour at least 8 grams of sample material into the barrel and use the charging tool to compress the material and remove any voids or air bubbles. Once completed, you can begin the preheat time for the test. On completion of the preheat time, the user must select to begin the test and the initial starting cut will be made. The test will then continue with cuts being made at the predetermined intervals. The auto cutoff device is designed to flick the material away after each cut, ensuring that the test area remains clear of material and all cuts are clean and consistent. The user may need to monitor the test to prevent any pieces of extrudate from sticking together, carefully handling any extruded material that is still hot. When all cuts have been made, the user must weigh each extruded piece individually. The masses can then be entered into the MFR300 by giving either the average of all pieces or, for greater results detail, the mass of each piece individually. It is advised that masses are entered to at least 3 decimal places. With all the masses entered, the results are then displayed. Along with detail of the test parameters, the average sample mass and melt flow rate are displayed. The user can either discard or save the result, with options to complete another test or end the current batch. A weight load erase warning must then be acknowledged before the system returns to the home screen. Next up is the density test. Again, the operator and material being tested must be selected before the test type is chosen. As well as test temperature and preheat time, the total test distance must be defined and the cutter and weight loader enabled as required. The test parameters can be saved against the batch alone or the material reference for future tests. Moving the encoder arm through its entire travel will zero the measurement in preparation for the test. After completing the cleaning procedure and charging of the barrel, the piston must be inserted and the encoder arm moved into position. The preheat can then be started. Following the preheat, the test begins automatically with an initial cut being made and a countdown of the piston travel shown. The test ends with another cut being made and the mass of the extruded piece is entered via the touchscreen. The melt density of the material is displayed and should be recorded for any subsequent Method B tests. For the Method B test, the test weight being used must be entered as well as the test temperature and preheat time. The melt density for the material is then entered. Along with the test distance and the number of slices to be recorded. Each slice consists of a recording of the instantaneous MFR result so that the profile of the entire test can be reviewed and any seemingly erroneous slice results identified. The test parameters are then saved against the material reference or batch, and the piston zeroed by moving the arm through its full travel. With the barrel temperature stabilised, the barrel can be cleaned and the piston preheated if required. The barrel is then charged and the piston inserted with the encoder arm being moved into position. From this point, the test will run automatically until its completion. The weight loader lowers at the predefined holdback time, and the test extrusion begins and counts down to completion. As well as melt volume rate and melt flow rate results, the system calculates a number of other test results, including shear stress, shear rate, viscosity, and apparent intrinsic viscosity. The profile of MFR slices can be viewed on screen. In this test, we can see that the final slice reading appears to be too high, possibly due to an air bubble in the polymer melt. This can prompt the user to discard the final slice within the Technitest software, so that the results are recalculated, producing more accurate average values. Saving the results shows the overall batch statistics before giving the user the option to continue or end the batch. A weight load erase warning must be acknowledged before the system returns to the home screen. The final method to show is for method D. Following the operator and material selection, parameters for the test incorporating two weight levels can be entered. The first test weight and extrusion distance are entered, followed by the second weight level and test distance, as well as the other normal parameters. Dwell time or distance is then added, allowing for some run-in between the first and second tests. Once the preheat is completed, the first test will run its course before the user is prompted to swap the weights over. This can be done manually by hand or with the weight loader. The dwell distance will then complete before the second test begins. At the end of the test, the results for both the first and second tests are shown, with the final result being the flow rate ratio between the two test masses. After acknowledging the weight load erase screen, the system returns to the home page. When all testing is complete, it's important to remove the test die so that it can be cleaned. The MFR300 keeps melt flow testing simple, but allows users to complete the full range of melt flow methods within a compact footprint. It represents a market-leading return on investment and is a must-have instrument for any polymer testing lab.